All right, welcome to day 15, September 28th, geometry. On today's agenda, we're going to talk about two things. We're going to talk about what's called an angle bisector and a perpendicular bisector. And I think I have them upside down. I think I'm going to talk perpendicular bisector and then angle bisector. You need to take notes. You will be uploading a picture of your notes in Schoology. That is part of your classwork today. It is part of your assignment. So as you're taking notes, please feel free to press pause on the video while you are watching so you can write things down. Take good notes. They will be helpful as we start building up and getting ready for our test that's coming up. So perpendicular bisector theorem. That's the first thing that we're going to talk about. If a point is on a perpendicular bisector of a segment, so right there, we've got some words in there that we definitely had some challenges with on the last test. First of all, a line segment is a portion of the line. It has a starting point and an ending point. That is a picture of a line segment. It is labeled because we do need to label the endpoints. We are going to call this line segment AB. So this is its name. This is its picture, and those are the labels. So the picture and the labels are down here. So when you take a look at your concept assessment from last unit, we do need to be able to identify the types of things that we're actually looking at. We need to be able to identify what a line segment it is, what it looks like, how we label it, and then how we name it. Notice the name gives us our initial point and our ending point and has the line segment symbol over it. Okay. So if a point is on the perpendicular bisector of the segment, so we are going to cut line segment AB in half. Whoops. We're going to attempt to cut line segment AB in half. Nope, that's not a good one either. All right, sorry. All right, so let's say we've cut line segment AB in half. It's not quite in half, and so let's delete it. So we cut line segment AB in half. So let's say it intersects at point C. That means this piece AC and this piece CB are congruent. And let's call this D. So AB is perpendicular to DC. DC being the segment that is intersecting AB. Okay. What does that mean? Why is that important? And where are we going? So if a point is on the perpendicular bisector, so the perpendicular bisector is DC. So if a point is on the particular bisector of the segment is AB, then that point is equidistant meaning same distance from the endpoints of the segment. Well, the endpoints of the segment are A and B. So that means, let's say this is point X. Point XA and XB are congruent. XA is congruent to XB. We could change it. We could move that point around. We could say maybe it's point Y. And then YB and YA are congruent. Notice I'm changing my symbols to indicate 3 lines. But we have that idea of things being congruent. And it looks like my screen share stops. So I'm going to press connect again. Sorry. So now you can see that the orange XA or YA and YB. So here at YA, YB, you can see that they are congruent. Good. You can see me drawing again. All right, so what does that look like? All right, so example 1, OQ, let me highlight as we go. OQ is the perpendicular bisector of MP. Okay. Which line segments are equal? So if OQ cuts MP, then that means Q is on the perpendicular bisector. Thus, MQ is congruent to PQ. Okay. MQ is congruent to PQ. Now we can find X because these two things are the same. So let's highlight the ones that are the same. 11 and 4X plus 3 boils down to a single variable equation again. 11 equals 4X plus 3. We're going to solve this single variable equation. Like I've been telling you, we are going to do a lot this year, pretty much all year. So 4X is equal to 8 divided by 4. Gave you the answer. X is equal to 2. So now the question is LQ on OQ? What do you think? Is LQ on OQ? So if I were to extend OQ, is L going to be on that point? Well, if I extend this, it appears visually, but again, we don't trust our visuals. We do need to ask ourselves, is it truly on there? It appears that L is on OQ. Part of the reason why is because we know that L is equidistant from M and P. So I believe that L is on OQ. All right. Example 2. Determine if ST is a perpendicular bisector of XY. Explain why or why not. What do you think? True or false? Is ST the perpendicular bisector of XY? All right, I'm going to go with no. Yes. This and this are congruent. Was there any indication that ST is perpendicular to XY? Could ST not be perpendicular to XY? And could they still be the same? Like, what happens if visually we cut it like this? Those two are clearly not congruent, And ST is definitely not perpendicular. But we could still have the same distances there. So that would be our answer. All right, example 3. MO is the perpendicular bisector of LN. So I know MO, this is perpendicular to LN. LO is 8. Would anybody like to hazard a guess what ON is? O is on the perpendicular bisector, therefore LO and ON are congruent, and ON is equal to 8. Again, remember, you can press pause so you can write down these examples as needed. All right, find the X and the length of each segment. What is WX? WX, there's your segment, is a perpendicular, and actually WX is actually a line, so we should put those line symbols. That's the name. WX is perpendicular to ZY. ZX is congruent to YX. So that way I know X is at the bisector. It's at the midpoint. So that means 2X plus 11 has to equal 4X minus 5. We're going to go ahead and solve. I'm going to move the 2X so I keep my X's positive. Look at all these single variable equations, ladies and gents. 2x is equal to 16, divide by 2, x is equal to 8. Once we know x, substitute back in. Now let's find y. 2 times 8 plus 11. 16 plus 11 is 27, and that's WC. Kind of cool, huh? Find the value of x. M is the perpendicular bisector. Since I'm telling you it's a perpendicular bisector, these two pieces are equal. 3x minus 8 equals 2x. Let's subtract 3x. Negative 8 equals negative x. Divide by negative 1. X is equal to positive 8. That's it. Hopefully perpendicular bisectors make a little bit of sense. There are some problems that I'm gonna have you guys do when you're finished. Angle bisector. If a point is on the bisector of an angle, then that point is equidistant from the sides of the angle. All right, let's draw an angle. A, B, C. So that's an angle drawn and it is labeled. It is called angle A, B, C. Again, remember the vertex needs to be in the center. Froze, so we're going to stop sharing. We're going to share screen again. It's all good. Technology. So there's my angle. Okay. So I'm going to draw a bisector. So a bisector is going to cut ABC in half. So that means that is congruent to that. So that means angle ABX is congruent to angle CBX. That's how I know BX is an angle bisector. This symbol here indicates that those two angles are congruent to each other. So the second part of this says that the sides are equidistant from the angle bisector. When I measure distance, I always measure distance as a perpendicular line. So I measure perpendicularly from any point on this, any point on the angle bisector, any point is equidistant. So if I call this point P, and let's call this O and Q, that means not B, P. That means PQ is congruent to PO. We also know that PQ is perpendicular to AB and PO is perpendicular to BC. Naming it. Now let's look at a couple of examples. All right. Is there enough information to determine that AB is the angle bisector of CD? So first of all, we do see that these pieces are congruent. But what do we also need? When the point is equidistant, what did we say? We said that the distance needs to be perpendicular. So taking a look here. Do we know anything about BC and CA? I don't know why it keeps freezing. Do we know anything about BC and CA? Do we know that they're perpendicular? So we're going to answer this. Is there enough information? We're going to say no. We don't know if BC is perpendicular to CA and if BD, that's a D, case you didn't know. If BD is perpendicular to AD. Unknown, so therefore we can't go further. All right, this time I'm telling you that MO is the angle bisector. We just need to find X. So if X is the angle bisector, what did we say is true about these two pieces? Yep, you're right, they are equal. 4X minus 5 equals 23. And oh my goodness, you're right. It's another single variable equation that we have to solve. I don't know why we did that at the beginning of the school year and why I keep harping on it. Craziness. I'm going to add 5 to both sides, guys. 4x is equal to 28. Divide by 4. X is equal to 7. One more example, that's it. Telling you this is a short video. 100-degree angle is bisected. What's the measure of the resulting angles? Any thoughts? Don't call it out. Not everybody at once, please. All right, you're right. The angles that are resulting, the resulting angles are 50 degrees. Bisect means what? Cut into 2 equal pieces. So what am I going to ask you guys to do with this? Well, if we go back to the iPad, we are going to go into Schoology. You are going to enter into our course. I'm going to just pick 1A, Unit 2. So you're going to locate this video in the notes upload. That's where we are. This is where you are going to upload a picture of your notes that you take. Here is our worksheet. Your worksheet is just a PDF. You are going to do these problems in your notes. There are 16 problems that you need to work on today while I am gone. Okay. Please feel free to drop me a remind message if you're having a question. I might be able to check them while I'm on the Spirit Bus. First period, do a good job with the lockdown. Fourth period, you guys will be heading into the building around 3:10 for when the Spirit Bus returns. So hopefully I'll see you there. Have a great day. The other thing that you can do is if you finish this worksheet, I'm feeling a little generous. I'll let you do late work on Delta Math for 50% of the original credit. So check out Delta Math and see if there's anything you owe me. All right, talk to y'all later.